This is part 2 on our section 6.3. We're going to use angle, angle. Here's a standardized test practice question. A flagpole casts a shadow that is 23 feet long. At the same time, a woman standing nearby who is 5 foot 3 inches tall casts a shadow that is 100 inches long. How tall is the flagpole to the nearest foot? We're going to do a lot of problems like this. This is one of my more favorite exercises in the entire course. You might not see it, but there's two triangles, this being the flagpole, this being the lady. They're standing at a right angle, or at least they should be. When you measure yourself, you should be standing at a right angle. She's 5 foot 3 inches tall. This flagpole probably should be standing at a right angle as well. We don't know how tall that flagpole is. But we have the sun, which creates sun rays that are parallel to each other. If the sun rays are parallel, what that does is that's going to create congruent angles here. Probably should have said it a second ago, but this segment down here is the shadow that's created from the sun rays hitting the top of the flagpole. Same thing here. This is a shadow. We know that the shadow length here is 23 feet, and over here it's 100 inches. So notice how the sun rays create triangles, and the two triangles are similar by angle, angle. Similar triangles by angle, angle. That's really important because if these weren't similar, you wouldn't be able to set up this type of exercise. This is called an indirect measurement exercise because we're not directly measuring the height of the flagpole. I'm not climbing up the flagpole with a tape measure and measuring it directly. I'm using other information that I could obtain easily to figure out how high that is using math. So here's what we're going to go with. Since these are similar, this to this is going to equal this to this. So 23 feet to 100 inches is going to be the same thing as x to 5 foot 3 inches. And that's your proportion. And this is a more complicated problem to start with because notice how the units are all different. This is feet, this is inches, this is mixed. We probably should find some common ground here just to make things easier. There are other ways, but I think this is probably going to be the approach that we take. Let's change 100 inches into feet. I'm going to divide by 12 because I know 12 inches go into 1 foot. So if I have 100 inches, how many feet is that? That's 8.33333 feet. So if I come over here, 100 inches is the same thing as 8 1/3 feet. That 0.3 repeating, that's 8 1/3. Now, you could display your number like that if you want to, or you could just take this mixed number and change it to an improper fraction. So we'll call this 24, when you multiply, add 1, 25 thirds. And again, I know that's a fraction, and you probably aren't a huge fan of using fractions, but it's a number. Now over here we have 5 foot 3 inches. So we know this is going to be 5 point something. How many times does 3 inches go into a foot? 12 inches in a foot, 3 goes into 12 4 times. So it's not 5.4, it's 5 1/4 feet, or 5.25 feet. Okay, so we have two similar triangles, cross multiply. So we're going to take 23 times 5.25. And then you're going to divide by the other number, 25 thirds. So we're dividing by 25 divided by 3. This is the height of the flagpole now. And since I made all of these dimensions in feet, that's in feet as well. So if we go back to the question, how tall is the flagpole to the nearest foot? Well, if you're rounding to the nearest foot, we would have to round down to 14. What if? What if a child who is 58 inches tall is standing next to the woman with the dog? How long is the child's shadow? Okay, so same situation here, except now we have a child. You're still going to have similar triangles between the big one and the small one because the child should be standing at a right angle. The sun rays are parallel. As long as this child is standing in the same zip code as these other people, your sun rays are going to be parallel. The child is 58 inches tall. How long is the child's shadow? Okay, well, we know this is 14.49 feet. We could change this into feet too, just to make things a little bit easier. Not that you have to, but we're going to use this 14.49 that we figured out in the last problem, and we're going to compare that with the child's height, 58 inches. But how many feet is that? 58 inches divided by 12 gives you 4.83 feet. So what that means is 12 times 4 gives you 48. You got 10 inches left over. So 10 inches out of 12 left over. 10 twelfths is 5/6. So this is 4 and 5/6 feet. And again, maybe you don't like that mixed number. You can change this. 4 times 6 is 24 plus 5. We're going to call this 29/6 instead. Probably a little bit better, a little bit safer. Okay, back to the problem now. 23 feet compared with whatever this is. These are shadow lengths now. So we're going height to height equals shadow to shadow. We'll call it y this time. We're going to cross multiply. So we're going to take 23 times 29/6. That gives you that ugly number. Then divide by that number. And that gives you this. This would be the height of the child in feet. And I'm not sure exactly how they wanted us to round. I'll just round to the nearest hundredth. How long is the child's shadow? Yeah, so 7.67 feet is what we'll say. You are standing in your backyard, and you measure the lengths of shadows cast by both you and a tree. Write a proportion showing how you could find the height of the tree. All right, so there's you. There's the tree. I'm assuming the tree is taller than you because this is an indirect measurement exercise. You could probably directly measure the height of a tree if it's shorter than you. Now, you know how tall you are. You can definitely measure the length of your shadow, or somebody can help you do that. You can definitely measure the length of the tree's shadow. So we're going to do your height divided by the tree height. And you're going to set that equal to your shadow, and I'm talking about the length there, divided by the tree's shadow. And again, that would be the length of that segment. So this is the proportion that you would need. Of these four things, you know three of them. You know your height. Somebody can measure your shadow length. You can measure the tree's shadow length. You don't know the tree's height, but if you know those three things, you can definitely find it by cross multiplying. That's indirect measurement.